So thank you for coming to my talk. I hope everybody's having a good conference thus far. A little bit of pressure. I don't know if I'm a good speaker. We'll see. If I speak too quickly or you don't understand what I'm saying, please feel free to interrupt me, ask questions. I do have an ambitious slide deck, though. So before I get started, can you raise your hand if you've worked with RabbitMQ before or are familiar with it? OK. That gives me a little bit of a judge of how much I should spend, or how much time I should spend in individual areas. So before I get started, a little bit about me. My name is Gavin Roy. I'm the VP of Architecture at AWeber Communications. We are an email service provider. If you use Python and have worked with RabbitMQ, you might be able to blame me for some things. I'm the author and maintainer of Pika, which is the semi-official Python library for RabbitMQ. I also have an opinionated RabbitMQ library called RabbitPy, and I also write plugins for RabbitMQ. So at least with RabbitMQ in mind, those are my credentials. I'm also the author of RabbitMQ in Depth, which hopefully will be finished in the next month or so and going to print soon. So you came here to hear about RabbitMQ and AMQP, and I want to start with AMQP because in many ways, RabbitMQ gets its primary identity from AMQP. And so it's important to understand what AMQP is because it then implies or puts behaviors on RabbitMQ as far as how the constructs and the concepts within RabbitMQ work. So AMQP is an open standard, and it was designed to be platform and vendor neutral. So if you're a closed source enterprise guy, boo, right? It works for you. And if you're an open source, open platform person, it works for you as well. Yay. And there are multiple versions of the protocol, and this is really important because it creates confusion in the community, and it creates confusion in people who are adopting the technology for the first time. So to speak to that a little bit, let me give you a bit of history. The timeline for AMQP. It's actually a relatively new protocol and as far as the internet is concerned, but it still has some age behind it. It was started in 2003. In 2005, a working group was formed, a consortium of representatives of organizations who had a vested interest in creating this platform and vendor-neutral messaging format. You'll see in the next slide that that consists of a lot of banking organizations and, to a lesser extent, technology organizations. In 2006, the working group released AMQP 0-8. And 0-8 is the primary identity version of where RabbitMQ originated from. And then in 2008, they released 0-9-1, and that is the primary version that RabbitMQ uses today. In 2011, the working group spun off and became a member of Oasis. And as part of that drive towards a standards organization having control over AMQP, they also released AMQP 1.0. Notice the difference in the dashes in versions and normal dot notation. The protocols are that different too. So AMQP 1.0 is a completely different protocol for the most part than the previous versions of AMQP. And for that reason, I'm not going to talk much about AMQP 1.0 other than what I've just said. I'm actually going to focus primarily on AMQP 0-9-1. So I mentioned the working group, and the working group, as you can see, has a lot of names that you'll recognize in it. And it's for that reason that I think AMQP has garnered the attention that it has, and one of the reasons why RabbitMQ, amongst other AMQP brokers, has been as successful as it has as far as adoption is concerned, and work within that standards area. So I mentioned that they're competing standards. AMQP 0.8 and 0.9.1 are very closely related. What happened was during that evolution, 0.9.1 deprecated some of the things that were unused in 0.8 and gained some new functionality, but by and large was the same protocol, whereas 1.0, as I mentioned, was different. So why AMQP 0.9.1? It currently has wider support, at least in the open source world, than AMQP 1.0. And there are multiple broker implementations. You can leave this talk and run out and grab any number of open source broker implementations for AMQP. And it specifies, as far as the protocol is concerned, both the binary on the wire protocol and a model, the organization and language that brokers and clients speak together with. I mentioned that there are a number of brokers. There are also a number of clients. As you can see, there's probably not a modern language or even a less modern language like COBOL that's not represented as far as having a AMQP client library. Some of these languages have RabbitMQ specific libraries, and I'll speak to why that is later. So what is the AMQP model? The model defines the constructs of how things interact with each other in the AMQP protocol. And in that, it defines an exchange. And it's really simple. An exchange is just the entry point by which messages are routed through a system. And those messages are routed through the system to other objects in the system, primarily queues, via a binding. So you can publish to an exchange that can be bound to multiple things, those multiple things being queues predominantly. Depending on what type of exchange you're using, you'll have different bindings. But traditionally, a binding is going to look like a string of some sort. It could either be just a word, or it could be a period-delimited phrase, name-spaced, that sort of thing. And when you publish a message, you publish it with a routing key. And that routing key matches against the binding when the exchange is routing it. They're provided when you publish the message, and they usually provide context around the message that you're publishing. It's really good to use contextual things in your routing key so that later on, when you're reusing that message for something you didn't originally intend, it's easy to identify, easy to route. So it could be something that specifies the type of a message. If you're a social network or some sort of online presence and users log in, your routing key might be user.login. Or it might categorize the content in the message. If you allow users to upload images to your site, it might look like something like image.jpg or image.png or image.gif, saying that the content in it has some sort of direct relationship to that key. Or if you're implementing something like an RPC implementation where you're publishing messages that some sort of application is going to process in the back end to answer a request for your front end application, it might be something specific about the type of consumer or worker that's going to receive the message. And there are a lot of other uses for it. These are just examples. So we talked about the model. What about the protocol? The protocol was designed to be a compact binary wire format or wire format for communicating between servers and brokers, or brokers and clients, I'm sorry. It's a bidirectional RPC protocol, which is something that we're not used to generally with internet protocols. If you, for example, are making a web request, you're saying, hey, give me this, and the server responds. You're not saying, hey, give me this, and then you're waiting around for the server to say, oh, by the way, I want you to do something for me too. And that's an important thing to think about with AMQP. The server can send commands to the client just like the client can send commands to the server. So as an example, this protocol specifies classes and methods for those classes for the communication that occurs. And so when we're dealing with queues, we have queue as the class, and a client would say queue.declare, and we'd pass in parameters like the name or any other attributes about the queue. And the server responds with queue.declare OK. And then it also gives us some metadata about the queue, how many messages are in it, how many consumers are connected to it. So I mentioned a few things that I actually didn't set up ahead of time. So some common terms, a broker is a server that implements AMQP. It's the thing that receives the messages, queues the messages, and sends it out to consumers. Consumers are the client applications that are receiving messages and acting on them, and publishers or producers are the things that are putting messages into the broker. You can have publishers that are consumers in the case of RPC applications, and you can have consumers that are publishers as well. It's just a common way to think about the different types of behaviors that interact with the broker. Clearly illustrated here where the P is a publisher and C is a consumer. We publish into RabbitMQ, we receive the message. One of the nice things about message brokers is I can have multiple publishers, and I can have a single consumer. Or I can have a single publisher and multiple consumers, or any combination of that I want to have. So AMQP messages, that's the crux of what this does, right? We're sending messages, aside from the RPC command, that one application wants to get to another. Well, in the AMQP protocol, those messages consist of 3 or more frames. The first frame is a method frame. It's that thing that says class.method. It's the command that we want to run on the broker, and we're actually saying basic publish. And when the server sends a message to a consumer, it's sending a basic.deliver. But otherwise, the rest of it's the same. We carry a content header, and that content header has a couple things in it. Most importantly, the size of the message body, but it also has message properties along with it that I, as a programmer, can use to specify things about the message, like a timestamp of when the message originated, or the type of message that it is, or a unique ID for the message, or a correlation ID for the message that says it's associated with something else. Now, I say 3 or more messages. Every frame on the wire in AMQP has a maximum frame size of 128K. So when you send large messages, what happens is the large message body gets chunked into individual frames, n frames, which is the size of the message body divided by 128K. This becomes important when you're thinking about using RabbitMQ at scale and how you think about how your applications communicate, packets per second on your switches and things like that. It also goes to how big, for example, your Ethernet frame sizes are, your MTU settings in your operating system, and that sort of thing. So AMQP sounds great, right? But there are some gotchas. For one, the spec leaves ambiguity in specific areas for the protocol. And if you're curious as to what those are, the rabbitmq.com site actually lays out what those very specific, ambiguous areas are, and the decisions that they made as far as implementation is concerned to be specific where the spec was ambiguous. Another issue is AMQP on its own with regard to authentication. If you try and authenticate with the base protocol with a server and it fails because of a bad password or SSL certificate issue or whatever the reason may be, you just get disconnected and you're not told why. And so that can cause problems. Fortunately, RabbitMQ has a solution for that, and I'll get to that in a minute. I mentioned that it was a bidirectional protocol where the server can issue commands to the client and the client can issue commands to the server. Well, that can trip some people up. It can trip library authors up. And it tripped me up originally. So for example, RabbitMQ by default says, every 5 minutes, I'm going to send a frame to you that checks to make sure you're still alive, called a heartbeat frame. Well, if you're writing in a single-threaded environment, let's say you're writing a C application, and you write a publisher that's just publishing messages as fast as it can, and it's not listening for requests from the server, you'll get disconnected by RabbitMQ within 5 minutes because you're not responding to the request from the server that says, hey, let me know that you're still alive. And that transcends many different areas in the protocol. I mentioned authentication. There's another step that is a little troublesome in AMQP, which is the connection negotiation. There are a synchronous exchange of 7 frames that occur on every connection to RabbitMQ. So when you open a socket, the client sends a frame and the server responds. And that RPC language or the RPC interaction happens multiple times before you could actually even publish a message for the very first time. So for languages like PHP, where you run a single page, you connect, you do something, and then you disconnect, it can be problematic at scale because there's a lot of overhead associated with negotiating that connection. It's where it excels with languages that allow you to have persistent connections with state. And that's an important piece too, because those connections are stateful. And even though PHP can hold open sockets across requests, it cannot know what the state of that open socket was in the previous request with the current request. And finally, exceptions. One thing that I see trip people up a lot is that command, that RPC interaction is actually, doesn't handle errors very well. Or I should say it handles errors very well, but it trips people up because what it actually does is it raises exceptions that close the channel that you're communicating on. And it gives you an error message in that closing of the channel that says you tried to do something you weren't allowed to do. And, but generally people want in their programming libraries, like, publish this message and tell me a Boolean response. Did you publish it okay? Yes or no? Not publish this message and then all of a sudden my connection is closed and having to deal with that. So it can be a little rough around the edges when you're first getting started to figure out those types of details about it. So I've covered pretty much a top-level overview of AMQP, and with that, let's move into RabbitMQ. So RabbitMQ is open source. It's released under the Mozilla public license, which is nice because some of the licensing around it originally was dual GPL and Apache, I think, if I remember correctly. But after acquisition and all of that, lawyers worked out to where basically it can be MPL. So don't sue them. Use it for what you want to use it for. It's written in Erlang OTP, which is really interesting. If you look at a lot of the other message brokers out there, they're written in Java or they're written in C. Erlang offers something that those languages don't natively, which is the ability to cluster and communicate across nodes and have this idea of message passing built right into the language. So inherently, it makes it both easier and puts more work on the programming environment, the virtual machine, to be a message broker. It's developed and maintained by Pivotal. So the evolution there was originally a company called RabbitMQ Limited, I believe, in London. And it was a collaboration between two companies. It was purchased by VMware. VMware spun it out to Pivotal. And it's multi-protocol. So I mentioned before, I wasn't going to talk a lot about AMQP 1.0, other than to mention that there's a plugin that's distributed with RabbitMQ that implements AMQP 1.0. So if you want to use AMQP 1.0, it's there. It also supports MQTT, which is really cool for things like mobile phones or Internet of Things, right? Stomp, XMPP, UDP. There's a lot of plug-in protocol support. If you want to have your web browser talk directly to it, there's a JavaScript library and a plugin that allows you to do that as well. But when it comes down to it, the identity of RabbitMQ at its core is AMQP 08 or 091. In the constructs, the way that it thinks, the way that it deals with messages and queues. So who uses RabbitMQ? You probably recognize at least a few of the names up there. Some of the more interesting uses that I've heard of, there's a series of underwater sensors for detecting sound. And they take the particular organization, I'm forgetting the name, but they take all of that data that come from these sensors. They then publish that data via RabbitMQ that makes its way into EC2, and that's where they do all their crunching of the data. India has a large biometric database, and it uses RabbitMQ to transfer information between the nodes related to that ambitious project of having that biometric database for all of its citizens. You know, it was at the core of Reddit as far as dealing with comments and publishing and database rights. You know, it's been huge. It's a huge part of, or at least at one point, OpenStack and NASA's efforts there for deployment. It's part of Chef. It's part of Sensu. Lots of open source projects have come to use it as the central messaging piece for what it does. So why would you want to use it? Number one, for me anyway, is it allows me to create loosely coupled applications. And what I mean by that is it allows me to create applications that scale easily by separating out the different components of an application into pieces where I can either scale out from a compute perspective, specific workloads, or I can decouple writes from a database. It really gives you a lot of flexibility in how you write your applications, and also flexibility in how you grow your applications. Generally, when you're starting day one on your app, you're not thinking 5 years down the road of the different use cases of the types of messages that you're publishing. And in my experience, I found, hey, we could reuse this message for this purpose or that purpose. And it's really useful from that perspective. It allows you to communicate across platforms and applications. If you want to have some applications living in the cloud while other applications live in your own private data center, RabbitMQ makes a very good way to communicate data back and forth between those applications that survives the disconnects that may happen, routing issues. It allows them to be loosely coupled. It also has built-in clustering. So it allows you to scale out for growth, or it allows you to scale out for high availability, which is a really interesting use case. And one of the things that I like the most about it is it has a very extensible plugin architecture. You can literally write plugins that inject themselves right into the startup of RabbitMQ, or you can write plugins that augment functionality, create new exchanges, create new types of queues, connect to other types of systems. It's really powerful in that regard. And just to tell you, it's one of those things where once you start writing, if you're really interested in that space, it's really hard to stop writing plugins. So I talked about some of the flaws with AMQP. The RabbitMQ guys, along the way, as they were developing it, found those flaws, and they started augmenting AMQP. And this is, as far as I can remember, the full list of extensions to AMQP that exist within RabbitMQ right now. I'm only going to pick on a few, or pick out a few. Authentication failure. I mentioned in AMQP, it'll disconnect you without any message as to why. During negotiation, if you tell RabbitMQ that you support their authentication failure extension, it'll tell you why you're being disconnected and give you the reason so that you can act on it. Exchange-to-exchange bindings allow you to take two exchanges and bind them to each other, not just to queues, so you can come up with very complex routing mechanisms, which I'll show you in a little bit. Delivery confirmations provide a very quick way to have the broker say, yes, I've received your message and I've done something with it. There's a whole bunch of other stuff on here. I'm going to skip over it for the sake of expediency, though. So let me talk about clustering. Clustering is LAN only. It depends on the low latencies that you get in a LAN. So I couldn't, for example, run a RabbitMQ cluster splitting availability zones in EC2. Or I couldn't run a RabbitMQ cluster between my private LAN and an EC2 node or what have you using a VPN, because it depends on those low latencies. I'm sorry? In milliseconds. You probably want to stay, and I'm just kind of pulling a number out, in the 20 millisecond or less range in that area. But if you're thinking, what's the high-end tolerance, you probably want to use federation instead, which I'm going to talk about in a minute. It adds highly available queues, and highly available queues allow you to publish into one node in a cluster and have that message replicated out to all of the other nodes that are participating in that highly available queue, allowing anybody else to connect in, consume that message, and once it's been consumed and acknowledged, it will then remove it from that highly available queue that exists across all the nodes in the cluster. So should you lose a node, that message still exists in all of the other nodes. As I mentioned before, it leverages Erlang for its internal clustering. Erlang can be a little foreign if you're not used to Erlang as a language, and even if you're a functional programmer, Erlang can be a little weird with regard to some of the syntax in the way that you deal with things, such as configuration and whatnot, but it actually makes for a very reliable platform for something like this. And the differences, while on the surface may look scary, they're actually very close. Erlang's configuration format or the way that it puts objects together, for example, is very close to JSON, just different enough to be painful. So clustering is cohesive. I mentioned that with HA queues, you can connect to any node You don't have to have HA queues. I could have a queue that is locally declared on node 1. I can connect to node 5 and consume from it. Or I can connect to node 3 and publish and have that queue end up on, or have that message end up on any node. So you can connect anywhere into the cluster, and it's just like you're connecting into whatever local resources that you're trying to get on any individual node. It, as of this time, has multiple different strategies for how to deal with network partitions or node failures. So it'll try and auto-heal itself, for example, should a node go offline, and reconnect and deal with HA queues and where messages, the state of messages and that sort of thing. It's really important that when you get into clustering, and if you want to deal with auto-heal, that you look at the different types of strategies that are available there and pick the one that's right for your organization or your needs. And finally, one thing to point out with an asterisk is that clusters are manually configured, whether it's through configuration and you're saying these 5 nodes are part of a cluster, or manually via a command line utility. And I say with an asterisk because a week or 2 ago I released a plugin that uses the console service discovery daemon to automatically build clusters for you. So it's experimental. If you deal with RabbitMQ clusters, I encourage you to check it out and give me feedback as to whether it works or not. I mentioned that I wrote this plugin. These are just a few examples of plugins that are available for RabbitMQ. So the RabbitMQ team released off backend AMQP. It'll actually, when somebody tries to connect, it'll publish an AMQP message with the idea of a consumer replying that says, yes, let that person authenticate or not. I'm just going to run through a few of these. RabbitMQ toke. So RabbitMQ has a built-in way of writing messages to disk and persisting them. The RabbitMQ toke plugin actually replaces that method with using Tokyo Cabinet, with the idea of providing a more high-performance, high-throughput database backend for message persistence. There's a sharding plugin. So if you want to shard your data across multiple clusters in a transparent way, it does that as well. So all sorts of cool stuff. Moving on to message routing. There are multiple exchange types that come by default with RabbitMQ. There is the direct exchange, which is the easiest one. When you publish a message with a routing key, foo, it is going to end up in the queue for any queue that has been bound with a binding key of foo. Simple, easy. The fan-out exchange doesn't care about binding keys. It doesn't care about, or I should say, it doesn't care about routing keys. When you publish to a fan-out exchange, every queue that's bound to it gets the message. Topic is a nice combination, the best of both worlds. Because with a topic exchange, you can have it behave like a direct exchange. You can have it behave like a fan-out exchange, or you can do pattern matching in your routing keys, in your bindings, to be selective about the messages that you're receiving. And the headers exchange allows you to do something similar to that as well. In the content header frame I talked about before, when you're publishing a message, there are message properties. And one of those properties is a key value table called headers. And what the headers exchange allows you to do is do matching of values in that headers table for your routing. I'm not going to get into the headers exchange beyond that, but I am going to detail a little bit about the pattern matching in exchange binding keys. So in this example, you can see I have a routing key called namespace.delimited.keys. So if I create a queue and I bind it to my topic exchange with a hash or pound, I will receive all messages that are published to that exchange, just like a fan-out. If I do namespace.hash or pound, I will receive all messages where the routing key begins with namespace dot. If I do namespace.delimited.*, I'll receive everything that matches at namespace.delimited with anything after it. And I can, in the middle, inject namespace.*keys and receive everything with namespace, anything in the middle, and keys on the end. So provide some flexibility. The main difference between the hash and the asterisk is the hash moves all the way to the right without regard to periods, and the asterisk will stop at the next period that it sees within the routing key. So on that, I talked about the exchange-to-exchange bindings and complex ways of routing messages. Kind of scary, I know. But in this example, very contrived, I have a message that's published into a topic exchange. And I have 2 exchanges that are bound to that topic exchange in different ways. And then I've got queues that are bound to those exchanges in different ways. And I've got a queue bound directly to it. And you can see that the exchange-to-exchange bindings, are very similar to the queue bindings, in that that message that flows through ends up routed in any number of ways. It allows you ultimate flexibility. So if you want to chain fan-out exchanges to a topic exchange, or you want to, for example, use some sort of plug-in exchange type and have that as being bound to a topic exchange that's doing other things with messages, it's a very powerful paradigm to get to where you want to get. But I always recommend start with a topic exchange. And when that doesn't fill your needs, go to whatever else you need. In my book, I've got some performance analysis that shows the difference in publishing rates with the different exchange types, and you'll find that they're all pretty much in line with each other. So one of the nice things that the RabbitMQ guys added to the spec with regard to RabbitMQ are alternate exchanges. And what happens when you publish a message into RabbitMQ is you could have flags set. One is called mandatory, and what mandatory says is when I publish a message, if that message doesn't go anywhere, you need to let me know by raising an exception and closing my channel. Another way that you can deal with that is you can use publisher confirmations, and what publisher confirmations say are, RabbitMQ, tell me in a nice way when I publish this message, and you don't, and let me know that it went somewhere. And it'll either say it went somewhere or it didn't. In either of those cases, that puts the onus on the publisher to figure out what to do next. Alternative exchanges provides a way for you to asynchronously deal with those failures and recover from them outside of your publishing application. And so what happens with an alternative exchange is when I declare an exchange, I say, this is my exchange, and if I fail to route anything, route all those messages through an alternate exchange instead. And so in this case, a publisher sent a message, it didn't go anywhere, it went to the alternate exchange, and the alternate exchange put it into an unroutable messages queue. So now, my ops team or somebody doing a postmortem can go figure out what happened. In that same vein, they added dead letter exchanges. And what a dead letter exchange is a setting on a queue when I declare it that says whenever I reject a message that I've received from RabbitMQ from a queue, go publish it through the dead letter exchange. And so in this case, a publisher sent a message, it went through my normal exchange, it went to the queue, the consumer got it, and for whatever reason, the consumer said this is bad. And so he's rejected it, it went to the dead letter exchange and ended up in a reject queue. And so now I can look at it. A reason for using this, for example, could be that I'm expecting a message that is serialized in JSON, and when I went to go do a JSON decode on it, it failed. And so we need to see what's wrong with it. There are a huge number of Exchange plugins that do everything from storing messages in databases to splitting the messages up in different patterns for use. Or in the case of the reverse topic, allow your publisher to say what queues it should go to. You can randomly distribute messages. There's all sorts of good stuff there. So now some of the more fun operational stuff, performance considerations. So I have this nice little performance scale for publishers. And on the very far end there where you have the Rabbit, those are publishing messages with no guarantees. That means I'm publishing the message. I don't care if it gets dropped on the floor. I don't have anything set up. I'm just publishing, and RabbitMQ is listening to my fire hose. And as a publisher, if that's good, that's as fast as it gets. These things stack up. So these aren't or type of things. These are and types of things. So I could be told, tell me when I have a failure, confirm when I've successfully done it, send it to an alternate exchange, use HAQs. Transactions, one thing I didn't talk about is in the AMQP spec in RabbitMQ, you have transactions just like in a database. So you could say, begin a transaction, do all this stuff, publish these messages, consume them. Oops, something went wrong, roll back. And now everything went right back to the state it was before I began the transaction. That has some performance penalties. But you can see if I stack HA queues with transactions, it gets even slower. At the end, I have persisted messages. When I publish a message to RabbitMQ, I can set a flag that says, hey, RabbitMQ, you've got this message. Make sure you write it to disk before you do anything with it. It's slow. It's akin to writing to a database. So when you're thinking about using persisted messages, use the same logic and hardware provisioning that you use when you're writing a high write velocity database, right? You need to make sure that you have enough I/O capacity in that server to be able to write messages to a database at the velocity required to keep up with your publisher. Benchmark it. Well, what in essence happens is the publisher sends a message, RabbitMQ writes it to disk. Once it's written to disk and confirmed, then it puts the pointers to that message in the various queues. Once that message has been fully consumed, then it removes it from disk. So now, just that persisted message thing puts the performance bottleneck on your hardware and moves it outside of RabbitMQ. Any questions on that? That's a common gotcha that I've run into. People that are persisting messages not realizing that it's a full database level write velocity thing. Yes? That's where the plugins come into play. So I mentioned the Tokyo Cabinet one. I know that there has been work to do plugins for other persistence, and I've actually personally been working towards writing a plugin for persisting specifically to Postgres. So, yes? In the clustered queues. So that write has to occur, actually. Thank you for the next segue. HA queues. When I publish into a HA queue, I'm sending it into a single Rabbit node, but then the RabbitMQ servers have to synchronize with each other before they put it into their queue data structures. So if you took that same slide and encapsulated it right here, so I've got 3 times writes on the 3 different queues on the different servers.
So if you have flag it as persistent, then it has to make it to disk on all nodes.
Exactly. Exactly. So we've talked about publishing. Let's talk about consumer performance scale. It's much in the same way. I can publish them this really quickly if I set acknowledgments and I tell RabbitMQ I want you to pre-reserve n number of messages in a queue for me, and it'll send them over in batches, and I acknowledge them in batches. Or I can tell RabbitMQ, send me messages, and don't even worry about whether or not I think they're good or not. If I turn no ACK mode on, it's just going to send me messages, I'm going to receive them, and I'm never going to acknowledge that I got them in the first place. Kind of dangerous. I can consume with acknowledgments, so that's just standard QoS1. I've got a message, I can use transactions. You can see that's slow. There's another method for queues or for getting messages called get, and that is where instead of having RabbitMQ know that I'm somebody who's registering to get messages, I'm instead just saying, hey, give me a message one at a time. Don't worry about who I am, just give me a message. And that's the slowest way to go. So there are obviously operational concerns with running any type of software. RabbitMQ is not immune to that. So for that, you want to make sure that you're trending and monitoring. Use the RabbitMQ management plugin to expose stats via an API that can be collected in Nagios or Sensu or any number of third-party services. Basically so that you know what your message velocity rates are, you know where your bottlenecks are, and you can look for problems like queue depths that you're not expecting, and you can alert to that says, hey, all my consumers died off of this queue, and I've got 1 million messages in here. Go wake somebody up and have them fix the problem. One of the cooler things that I've wanted to do and haven't gotten around to doing is using a system like Riemann that does stream-based processing for stats. So that instead of looking to say, hey, I've got a number of consumers issue or I've got a number of messages issue, let that system actually build a trend of what that message velocity is and alert me when there's a deviation in the trend that's negative. Like I usually publish 100 messages a second and all of a sudden I'm publishing 10 messages a second. There's something that I have to do there. With regard to configuration, use configuration management. It'll save your butt when things go wrong. disaster recovery, for example. And if you can take and put exchanges and queue declarations and bindings in configuration management, it makes it even easier, because you don't want to be in the situation where you're doing some sort of disaster recovery and you have to figure out what all these different applications were that had all these exchanges and queues and bindings and stuff. If it's all in configuration management, you could, in a disaster scenario, say, you know what, I'm just going to provision a whole new RabbitMQ cluster with all the same objects in it, and so all I have to do is point everything where it's supposed to go. Really important. And I say that from personal experience after spending like 8 hours trying to recover a RabbitMQ cluster that went down, and I didn't have that stuff in config management. Use their policies whenever possible. Instead of directly setting attributes for whether it's federation or it is alternate exchanges, that sort of thing, use policies, because objects are immutable when they're declared. If I declare a queue and I want to change something about it, I actually have to delete it and then redeclare it. But if I use a policy, the queue never has to go away. Just the policy has to be removed or updated. We're almost out of time here. Let me show you a few sample usage patterns, and I'm just going to run through these real quick. Take your tightly coupled applications that are talking to databases and decouple them. Or listen for database notifications with the Postgres Listen exchange. Really helpful for debugging stored procedures and that sort of thing. Have Postgres send out its native notifications. Have RabbitMQ pick them up and put them in a queue. Multi-purpose your messages. Have a message go through that maybe is only going to be written to a database, but use it to trend stats in Graphite and send it out to a cloud service like Loggly or something like that. Take that one single-purpose thing and multi-purpose it. Use it for RPC. Have your application send a message that says, hey, worker, do this thing for me that's computationally expensive that I don't want to put on Node.js and have it block my loop. And then send back a response to me when you've got it. And then I'll send a response back to the client. And this one's dangerous, but it's a neat little hack. It builds on some of the constructs in RabbitMQ. Publish a message to an exchange with a queue with a TTL on it that says, after n number of seconds, delete the messages. When you declare the queue, also set a dead letter exchange. And what will happen is when the message gets deleted, it's going to be published to the dead letter exchange, which will then go to a ready queue. So I could publish a message and say, have RabbitMQ hold on to it for an hour before publishing it to another consumer. When you do this, if you ever do this, think about the implications of having a million messages in this queue and what it's going to do to either RAM on the node, that sort of thing. Don't just blindly go into it. Do some analysis around it. But it's a neat little trick using those built-in things in RabbitMQ to address that kind of workflow. So with that, do you have any questions? So in older versions of RabbitMQ, RabbitMQ would die. The question was, what happens when a queue gets so big that the machine runs out of memory? So in previous versions of RabbitMQ, the queue would die. In newer versions, and I haven't experienced actually running into this lately, so I can't tell you whether or not it works or not. It's supposed to, one, throttle your publishers and say, hey, you're blocked. I'm not going to let you publish anymore because you're causing problems for me. And two, it's supposed to deal with putting messages to disk in the background so that you don't run into those issues.
Is there any sort of authorization for who can publish or receive messages from queues?
Yeah, well, there are ACLs built into it for who can perform writes, who can perform configs, and who can perform reads. And those ACLs have regex assigned to them. So you can use regex to basically match against patterns of usernames, or I'm sorry, patterns of queues or what have you for those things, or the inverse of that. Yes?
Are there issues with protocols and ports and things like that? So say in a corporate network environment where there are restrictions on what ports you can run on, firewall rules, things like that?
There are no restrictions. If you need to change the default ports, you can change them in the config file. The one thing that is important that I've seen people run into is AMQP is a stateful protocol, as I mentioned before. So sticking it behind something like a load balancer, you need to make sure that that can keep track of that state. because if you're just load balancing across nodes and you're trying to keep those connections open, it can create issues. Well, great. I appreciate your attention. My publisher was nice enough, and I have to mention it because they were nice enough. If you are interested in picking up my book, there's a 43% discount using that code at manning.com/Roy. We should be done soon. I go into all the stuff I talked about here, but in a lot more depth. So there's that information there. And I hope you guys have a good rest of the conference.